Chapter 26.4, question number 2. Consider a series from n equals 1 to infinity of n to the power n. It says, show that if Sn is the sum of the first n terms of this series, then Sn minus Rsn is equal to the sum of r to the power I from I to n minus n times r to the n plus 1. Okay, so that looks kind of complicated, so we want to break it down a little bit. So firstly, there's a couple key ideas that we want to kind of think about while we're doing this. So one of them is how factors can be manipulated in notation. And secondly, how to account for the number of terms when we change the number of terms in the sigma notation. And we'll point to these as we encounter them. So there's a lot going on in here, but let's break this down a little bit. And first of all, we're just going to define Sn. Okay, so Sn is going to be this I equals 1 to n, and note that we're changing the notation from n to I just so that there's no conflict. So we're going to start at I, we're going to end at some finite value n, I r to the power I, and that's going to be how we defined Sn. So that's kind of what they're saying up at the beginning. So once we define the Sn, we want to set up a proof for this statement here. So we want to prove this. So we're going to show it as a 2-column proof. So we're going to set up the proof here. So we have Sn minus Rsn is equal to the sum of r to the power I minus nr to the n plus 1. So this is a proof. So what we need to do is we need to be able to make them look the same. So the first thing we're going to do is switch the Sn expression here into the sigma notation form. Okay, so we've defined it up here as I equals 1 to n, I r to the power I. So we're going to replace the Sn in both terms there, and we get this expression that looks like this. Okay, so I'm going to take this factor of r and I'm going to apply it inside the sigma notation. Okay, so what does that look like? So firstly, I'm just going to keep this part the same. I equals 1 to n, I r to the power I minus, and here we have I equals 1 to the power n, I to the power r to the power I times r to the power I. And that extra r on the outside, we're going to apply that into here. And so we're going to end up with an extra times r. So we're going to end up with I plus 1. So we're going to get 1 extra in that exponent. Okay, so that's the first part, dealing with that, how we can deal with factors in the notation. We can multiply them in like this, and we just have to account for it. So I'm going to then break up this expression, this plus 1. I'm going to rearrange it a little bit. So it's going to be I equals 1 to n of I r to the power I minus, and I'm going to express it in this way. So I'm going to go back 1 term. So I minus 1. And this becomes then I just plus 1. Or sorry, r to the power I. So this is a sum of all the terms up to the second to last term. So there's one extra term that I now have to account for. So I'm going to do plus. That last term is just going to be the nth term of that expression. So it's going to be n r to the power n plus 1. So all I've done is I've taken that expression, and the last term is going to be the nth term of that expression, so it's going to look something like that. Now, the reason why I do that is now you can see that this term here this term here now matches this term here. So that now I have an expression match. And in fact, if we take a look at the sign here, that sign is also the same. So I'm kind of getting to where I want to go now. I need to then generate this r to the power I. So I kind of want to get rid of this I r to the power I that happened at the beginning. Now, how do I do that? Okay, so first of all, I'm going to keep this the same. And in this expression, what I'm going to do is I'm going to distribute that to those two terms. I'm going to write them as two separate sigma sums. So I have the sum from I equals 1 to n. This is going to be I r to the power I. And I want you to notice that these are going to cancel out. Those two terms are going to cancel out. And then minus I equals 1 to n of r to the power I. And now I've generated the other part that I need for this expression. This part here is going to match that part there. So then I just have to clean this all up. So I have plus n r to the n plus 1. And then simplifying this out, these two terms cancel out. Okay, what's left over is going to be, watching the sign, it's going to be negative, negative, so it's going to be positive. I equals 1 to the n of r to the power I. Okay, that matches that first term. Minus, watch the sign, so it's negative, a plus, so minus n r to the n plus 1. So I've made my left side look like my right side. This is now proven that that expression that we started with is equal to the right-hand expression with the sigma notation.